Hello, this is Steph. Today we're going to see how to work with the bitmap images. So in particular, we're going to see how the BMP file format works. We're going to check how is the header of the BMP and what does it contain. And usually the people think that a BMP image is a simple matrix of numbers, which is true. So you see all the data of all the pixel values one by one in sequence, but in the beginning there is something more. So we would like to investigate what's in the beginning, and in the future we're going to see also other file formats. We start very simple with the BMP and then with other file formats dealing with multimedia, but not only. And if you please like, share, and subscribe, and hit the notification bell to get notified about the next videos I'll be releasing. Windows is ready, so we can get started. Okay, so one of the first things that we might do as soon as we want to get some information is to Google what we want, so BMP file format. Let's search on Google what we can find, and we have the BMP file format, the page from Wikipedia. And here you see that, first of all, one of the first diagrams that the Wikipedia page shows is the header of the BMP file. So the people might think that the information that we have, move my big face around, here is only the image data, but as you can see, there's a lot of information before. So we're going to see the metadata that we might find, and we are going to build a program to read this data properly. So let's go back. Wikipedia is pretty exhaustive in terms of information. So you see all the beginning, and you see all the meaning of all the data. So let's get started. We're going to see this in a Python program. Okay, so let me take a Visual Studio Code. I created a folder called BMP Parser. I make everything a bit bigger, maybe too big. Okay, and good. And here, create a folder called BMP Parser. So what I would like to do is a series of videos dealing with the analysis of some image and video formats, but not only. So maybe I will rename all this folder. At the moment we have this. So here, first of all, in the BMP parser, I would like to create an image, a BMP image, and just to be not so selective in the content, I created a Python program that makes a random pixel image. So here in this case we are going to use PIL. So if you saw the video the other time and you already have installed, you can use that environment. You can use any environment. There is nothing specific. I used the default or the one that we used the other time. If you don't remember, look at the other video to see so how to install all the thing. And so created a method, a function called create random image, though with the width and height selected by the user. Here I made it very little, 8 by 8, just to not to have too much data in the file itself, so we can take a look at the image in hexadecimal format in a single window screen. And here, so in the create random image, we have we create an image type RGB, and we load so the pixels of the image, and then with two nested loops, we created the RGB image, and then we have the image in the end. We save the image, and so we can run the program. And here, as you can see, we have a random image, 8 by 8 image. So with a matrix of 8 by 8 with all the pixels put at random. Cool. This is the first step. This is the image we're going to analyze later. Okay, so after that, I created a file, Python file called BMP Parser.py. So little by little, we're going to explain what the program does, what are the libraries included. So the libraries are not necessary to parse the BMP. Everything that I did was using the normal Python, so the default libraries, things that are in Python without the importing of anything. This is to use the thing in the end, so to open the image and to open the, so to interact with the software to open the image we want, basically. So this is to open the file name we're going to show you later. So first of all, what I would like to do is to get the header on one side and this on the other. So we can make a comparison of what is written in the program and what is written in the Wikipedia page. So sorry for my big face. I try to keep this up in the upper part like this. Cool. Good. So first thing, we have 2 bytes. That is the header field. This is to tell the opening software to say, hey, this is a BMP image. Usually you have 2 bytes and they are loaded as ASCII, as characters. So here we can, usually most of the times we have the BM. When you open a BMP image, so let me open the one that we have here, reveal it in the Explorer. Here we have the random image, and if we open it with a hex editor, you have this. So sorry that it is small. Let me check if Visual Studio can open it as hexadecimal. I think I have the, well, whatever, so that it can be seen here in the hex viewer. And here we have the first 2 bytes that are the BM. Okay. Then we have 4 bytes that decide the size of the image. The size, so 4 bytes, is read as little endian. So with the 4 bytes are read from right to left, not from left to right, as we usually read the data usually. Then we have a couple of bytes. They are so-called reserved. So I called reserved 1, reserved 2. And so they are both at 2 bytes. So I use the int from bytes method to extract the information as soon as we are reading it. Then we have the pixel data offset. So this is the offset from which we are going to read the pixel data. So I try to put the variables as self-explanatory as possible. And this is the first. This is, let's say, the header of the BMP header. So this is a BMP file header, and so it is right here. The second part of the BMP file is the DIB header. So the information we're going to read is a bit further within the file because we are using usually the Windows bitmap info header, and this is what we find here. We have the 4 bytes indicating the size of the header. Okay, still all the information is read in little endian. Then the width and height of our image, that is supposed to be in pixel. Okay. Then we have the number of color planes, but this value is always at 1. So this is information that is contained, but the plane is always, so this value should be 1 always. Then we have the bit depth. So how many bits per pixel do we dedicate to each pixel? So how many bits do we dedicate to each pixels? Usually this is 24. Why? 24 is 8 bits, 8 bits, 8 bits, 1 for the red, 1 for the green, and 1 for the blue. And this is the one that we read out of the file. There can be also something less, so 16 bits per pixel, or 32. 32 means that there is also a fourth channel, because the BMP, it is astonishing, can support also the alpha channel. It is not widely used and widely supported, but this can be used. And here we have also the compression method. The compression method is contained right here, and so we see later which is the value, but it is dedicated by 4 bytes, and the most common is the first. So I expect that most of the time we have the BIRGB, so this value is at 0. But if you want, there's also there are also other values. And then after that, we have the image size. The image size is the size of the raw bitmap data. Okay. Then horizontal resolution and vertical resolution. This is something that is not so intuitive, because we have maybe a weird value, but that value is in pixel per meter. So it is an integer indicating the horizontal and the vertical resolution of the image in pixels per meter. Then we have the colors in the palette. So usually it is either 0 or a default to the power of n. So if we have 24 bits per pixel, this should be 2 to the power 24. It's dedicated to a size of 4. And then you have the number of important colors. So I don't know so much the meaning of this, and usually it is at 0, because every color in the image it is important, and usually it is ignored. Also, the Wikipedia page says that. Okay, so after that we have the seek of the pixel data offset, and so we are going there at the beginning of data as they are, and then we calculate the padding of the rows. And so here we want to understand where to go to the new line. There is also the formula right here somewhere in the page, with also some examples. And so here we go. So the formula is essentially this for the row size. So it is the bits per pixel multiplied by the image width. So in this case, 24 times 8 plus 31 divided by 32. Okay, so in this case, it takes both, so the formula with the 4, no, it takes this this part right here. And so just in case there is a padding to be done, it does it. And then here we got the parsing of the pixel data. In this case, maybe I made a mistake before, because by default yes, since we are in let's let's say in Little Endian, the first that we find is the blue, because RGB on the opposite is BGR. So in this case, blue, green, and red. And then we have the storage of all the pixel data. And here, essentially, I wanted to take this data in a more explicit way. So now it's time to iconize the Wikipedia page and go back to the full screen of the program. So I wanted to store this information as a kind of a CSV file to inspect it a bit better later. And then it's going to print with the offsets already, so with the bytes already explicited with separation by spaces. And then in the end, we are going to use the libraries that we have in the beginning. So I use usually Pathlib because it's very comfortable to work with the files. I know that some of you might be comfortable with the OS join OS directives. So Pathlib is very comfortable. It is a thing that I suggest everybody to use because it's really a comfortable way to work with the files. And here, what you have is, so it's used pretty much here to get the path of the file, but I know that I would like to tell you that this is a very powerful library. So we want to take out the BMP file path, and I use the TK inter library, that is the file dialog. And so the ask open file name, you give a title to the dialog, and I use this folder as my starting folder. You got to select the file types. I also included something which is not BMP. So if you would like, if you have an image that is not a .bmp, maybe we can make a try later. This can work anyway. It will parse the BMP. I also put a line later to read the pixel data. So here you can add the, so you can see the pixel values as they are contained later. So we execute the program, and this window appears. So what you have, so here the only image I have in this folder is the random image.bmp, and this is the information that comes out. So here I can copy paste as it is. So to be a bit smart, I'm going to redirect this into the random. So I'm going to take this file right here with all the thing, and I'm going to rename this into a CSV. So instead of showing the output in the standard output, I'm going to create a file that is a CSV file in the same folder where the file is. So here, this is still my random image, and I should have the data here inside. I have the CSV extension right here to show the CSV a bit better. So we have rainbow CSV and edit the CSV to see the CSV data a bit better, a bit more colored, so to explicit the data from field to field. And would like to edit the CSV to see the table a bit better. Here I got to give the information that has header, because I put the first line with all the things. And here you have all the data of this image. So we see that the file size is 246 bytes. And let's have a look if it is true. So 246 bytes. Then We have all the reserved. You see that it is at 0. You got the pixel data offset. They start at 54 bytes, so 36 hexadecimal. And in this case, we are going to check the data here in the X file. I'm going to open my hex editor, and here this is where they should start. Here maybe it's very little. The offset is at 36, as it is rightly said here. Then you have the header size that is 40, okay, width and height 8 by 8, color planes 1, and all the data are contained here. So we share everything in somewhere, as always, in the here down in the video description. Cool. Just given the information, so here on the parser, I told you that here we can rename, for example, the BMP file with any file. So let's see, we're going to rename the extension from BMP to, let's say, any. Something that cannot be opened, but is still right there. So if I open the parser without executing, so here we don't find any BMP files, but we see all files. We can take the run image.any, and it works anyway. So here what we have is something that is not related to the so it is related to the BMP file because it reads the file as BMP. So let's hope that in the future we can build a universal parser out of it. So let's see. Okay, so today we saw a simple image format, but still, it's like this is the icebreaker for the other formats, and this will be the format I'm going to use for the next videos as well, dealing with this topic. Here, so okay, we said something about, so we made a program that is very specific for BMP data. Maybe in the future, something to be done better is to make something a bit more universal. So why not? We're going to build, a discover or universal parser. Let's see what comes up in the next videos. I hope you enjoyed it. If you do, please like, share, and subscribe, and hit the notification bell to get notified about the next videos I'll be releasing. And so what else I got to say? Thank you very much for watching so far, and see you next time, dealing with other videos, dealing with multimedia, but not only, because here I think that they're not only multimedia data that we can take a look at. And see you next time. Bye. Ciao. Ciao. Ciao.